Today we will discuss about what is polarimeter, how we use polarimeter, and the parts of polarimeter. First, what is polarimeter? Polarimeter is an instrument which measures the angle of rotation by passing polarized light through an optically active substance. Now we will revise our previous knowledge. Polarized light, optically active compounds, optically rotation. What is polarized light? Polarized light are the light waves which can occur in a single plane. In the image, you can see that at the right terminal there is polarized light. Polarized light can vibrate only in one plane. Optically activity. Property of compounds being able to rotate the plane of polarization of plane polarized light is called optically activity. The compounds with this activity is called optically active compounds. First part of the image you can see that the plane polarized light is rotated, and in the second part of the image it is not rotated. This light is rotated due to the polarizer's effect, so that the first compound is optically active and second one is optically inactive. Now we will discuss about parts of the polarimeter: sodium light, collector lens, color filter which can only allow sodium light to pass out, polarizer, half wave plate which shows the four regions: full bright, full dark, center bright, center dark. Sample tube is put inside this region, metallic jacket. After this region there is analyzer, object lens, die vernier, main scale and vernier scale, rotatory head, object lens. How to use polarimeter? We take water in the sample holder. Water is optically inactive. We will use water sample to check the working of our polarimeter. Put this sample and cover it with metallic jacket. Rotate the rotatory head until this image will appear.
Acid catalyzed hydrolysis of sucrose, which means breakdown of sucrose with water in the presence of acid. Here, sucrose is a disaccharide which have general formula C12H22O11, which reacts with water and form glucose and fructose. Those are monosaccharides. Here, positive and negative signs means their optical activity. Optical activity are of two types: dextrorotatory and levorotatory. If the compound rotate plane polarized light toward right, it is dextrorotatory and contain positive sign. If the compound rotate plane polarized light toward left, it is levorotatory and contain negative sign.
Let's prepare the solution. First we prepare the sugar solution. First we add the sugar in the beaker, then raise its volume to 100 ml. After this, we prepare the HCl solution. Add 3.67 HCl in the beaker. 50 ml water add in it. After that, we mix both the solutions. Add the HCl solution in the sugar solution and mix it. Now we will perform the experiment. First we fill in the sample holder pure sugar solution. Put into the metallic jacket and we will see that the full bright region will appear. Then the solution sample is put and we will see after 0 minutes the bright region will appear and the vernier scale 0 point will match the 30 scale. We'll see that after rotation this reading will appear. After 16 minutes this reading will appear. Now we will see after 25 minutes we get this reading. After infinity time we see this reading on the scale.
Now we will do calculations. For taking calculations, first we will see how to take readings. For noting reading, first we will say vernier scale 0 point is matching with which reading of main scale. Like 0 point of vernier scale is exactly matching with the 38th reading of the main scale, and vernier scale's 5th reading is exactly matching with the 40th reading of the main scale. Now we will take at 0 time. First, we will take that reading of the main scale that is exactly matching with the vernier scale 0 point plus 0.1 that vernier scale's least count into that reading of vernier scale that is exactly matching with the main scale. And then we will receive plus 30.5. Here, the plus sign indicates that the reaction mixture contains dextrorotatory compound. We came to know about this positive sign by rotating the screw of the polarimeter toward right. Now, we will take readings at 8 minute, 16 minute and infinity time. In the same way, here infinity time have minus sign with it. It means the reaction mixture contain levorotatory compound which is fructose. Fructose is present in greater amount in the reaction mixture, therefore we have negative sign. Now we will find velocity coefficient at different times. For 8 minute we will take optical rotation at 8 minute and subtract the value of optical rotation at infinity time from it. After this we will get 37.64. Now after calculating RT minus R infinity we will find velocity coefficient. For this, instead of 1 over T, put 1 over 8 log R naught minus R infinity we have calculated earlier, that is 42.34, divided by RT minus R infinity that we have calculated. After dividing we will get 1.12. Now take the log of 1.12 and divide the answer by 8. After dividing we will get the value of velocity coefficient at 8 time. Calculate its value at 16 and 24 minutes in the same way. Now question arises, why we do not calculate velocity coefficient at 0 and infinity time? Because when we calculate it at 0 and infinity time, the 0 comes in denominator and which is an error. Therefore, we cannot calculate it at 0 and infinity time.